speaker of the day, Mr. Sanjay Chittor, founder and CEO of Quantum AI Global and Q Labs, Hyderabad, has been instrumental in transforming complex quantum theories into practical, real-world infrastructures and applications. His work reflects a powerful transition from scientific exploration to national-scale technical advancement. In today's session, we will gain valuable insights into how quantum technology is evolving beyond theoretical frameworks and becoming a fundamental force in modern infrastructure and innovation. Please join me in extending a warm welcome to Mr. Sanjay Chittor.
Hello students, dear esteemed dignitaries who served the nation in the past. I just came to know some of your deans, faculties are from Baba Atomic Institute of Technology, DRDO. That's very inspiring. But before I start, let me tell you this. I'm not going to bore you guys. I'm not going to have any presentation here. I'm here to talk about latest technology which is evolving, which is quantum technology. My session here is aimed at giving you the basic awareness on what is this quantum, not by PowerPoints, not from books or Googles, theoretical or a practical knowledge, where it is applicable, what is this quantum. Just follow my words, how much ever you can understand, and I will try my best to give you the basic awareness so that it leads you to decide if you would like to get into this technology called quantum, right? So before I start, good afternoon, students, future innovators. Can I hear a good afternoon back from you? Why I have to ask you this is, I saw a lot of your students outside having this fruity, almost in everyone's hand. Having this fruity, I'm not against any brand or something, but guys, sugars are slow poison. Just avoid all those soft drinks, Cokes, Pepsis, not at all good. That will kill your body cells, it will kill your brain cells, it will make you lethargic. Having heard that good afternoon back, I still feel that a lot of people in this room did not have that fruity. Hence, there's that much energy. If you had, you wouldn't. Having said this, let me start. What is this quantum technology? How many of you know about quantum? Just raise hands, I will not ask any questions. 1, 2, 3, 4, 5. Handful. So in this handful, how many of you have done something in quantum? Okay. How many of you are from computer science? How many electronics? Electrical electronics, 1. How many are mechanical? Wait. This doesn't make sense. So, very few from computer science, very few from electronics, very few from mechanical. So, rest of the stuff, which faculty are you guys in? Madam? So many, very few hands raised. So, rest of the people, they are from what faculty? Like BSc, MSc? Everybody computer science. Engineering. How many are from civil? Okay, I give up, guys. So, before I get into this quantum, there are a few myths in this quantum technology. People are saying that quantum is only for computer science. Wrong. Anyone who is in mechanical, anyone who is in electronics and electricals, anyone who is in computer science, this particular technology, each one of you could adopt and make your careers in it. The second myth in the world, what is going on is, or in India rather than in the world, to do anything in quantum, you need a quantum computer. That's a myth. It's not true. There's only one segment in quantum which needs a quantum computer. So I'll get into this depth of quantum computer, what is this technology of quantum, where we are. in a little bit, but to start with, what is this quantum technology? Quantum is so far whatever digitalization advancements India had ever achieved. When I say digitalization, AI is part of it, GPUs, the superficial sensors we are talking about, radars, drones, whatever technology advancements India has or the world had achieved as of today, they are all combination of computing and electronics. You take anything, anything which is digital, from the car automatic start-stop button. We moved from the key start to the start-stop button. That's digitalization. Any of the advancements we got so far is computing and electronics together. Now, what is this quantum? It's a little different. Quantum is physics and electronics. The moment I say there it's computing and electronics and here physics and electronics, right here you guys can imagine there's a whole conceptual change. The entire basic way we operate, everything is going to change moving forward, and that's what quantum gets to the table. Quantum, in one line, it all started in 1900s, and then Einstein picked it up, and then there's another guy who redefined it. There are multiple people, there's Shor, there's that cat, what is that guy's name? Schrodinger, huh? Yeah, he came up with, I think, I would say quantum evolution started from him rather than Einstein or Paul, whoever it is. So it was there for years, but what was there is not quantum research. If you talk about digitalization, if you talk about computation, they have been for a few decades, but all those existed to advance the technology. So once upon a time, the regular computer was this big, your laptops were this big. Right now, your laptops became so small. So all these technology evolutions, when they all started for the technology advancement. Now, here is the deal with the quantum. Quantum didn't start for technology advancement at all, whoever researched in quantum. Quantum is bought by curiosity and confusion. Quantum was never a solution. Quantum was never meant to productize. How this whole quantum evolved is, when I say it's all based on physics, if any one of you think math is the toughest, I think a lot of you, including me, as I was growing up while I was doing engineering, or till recently, till 6 years ago, for me, math was the toughest subject. But honestly, if you really see, math might be tough, but physics is spooky. Math, every problem, there is an answer. Physics is a suspense. The real concepts of physics, there's so much of confusion, there's so much of curiosity. Few things even today, as of now, me being a quantum productization company, having market-ready products in quantum, having NQM invested, National Quantum Mission invested in us. We are part of, Government of India is one of our equity holder. Having achieved so much in quantum, even today I don't have basic answers, because quantum is based out of physics, and I'm not sure how many people will understand. I promise you I will not talk technical and bore you, but physics is only possible in physics. There are particles, there are waves. Basic physics we learned in waves can travel through. Particles cannot travel through. Once they hit, it's gone. Till it gets hit by something, they exist once they hit. So the properties of particles and waves are different. Waves, imagine there is a wall, and if there is even little space, waves can go through, or it can pass through some of the objects also. Whereas particles, once they hit, if there is no option, that's it, they are dead. Yeah. Hello? Is this better? Can you switch this off? Yeah. Is this better? Are you able to hear? Okay. So there is this concept in physics where light is a what is light? Light is bunch of photons. And Photons are quantum particles. The funny part is, even today, no one is able to figure out why light can take a form of a wave till it's not observed. But the moment you observe, it takes a form of a particle. How is this even possible? No one was able to explain this theory as of today. Quantum is based on this physics. Just imagine what is the power. I'm kind of helping you join some dots when I talk about the power of quantum, what it gets. I want you to understand why, then knowing what. If something is able to be in a form, which is a wave, and the moment you watch, it takes another form, it's not reducing the frequency or increasing the frequency of wave. It's totally converting into another form itself. This is the physics, unexplainable physics. This is the suspense. How it happens during Einstein times, or a few decades ago, everyone did research on quantum to solve the psychological puzzles. No digitalization, no technology, there is a psychological puzzle. The advancement in quantum is a puzzle to the brain. So quantum evolved out of curiosity, quantum evolved, research in quantum happened to get answers, but unfortunately still no one has answers. But what happened to the world is, okay, fine. Still some people are trying to find an answer on this simple concept of phenomena in quantum, but while few others, they started using these properties in quantum to develop a specific technology which can be a game changer for the world. So classically, I have a lot of research scientists. Most of my people are from IITs, DIITs, where there are a lot of quantum research going on. So one of the guys who's sitting here before me, my young scientist, who is the reason for one of our product called quantum memory, is here. The other day we were talking over dinner, and what he explained me really strikes me. I asked him, his mom is PhD in Sanskrit, and he is brought up in Varanasi reading every Upanishad. And casually I asked him, what got you to this quantum? You are that person, the Indian culture, Upanishads and all, and suddenly he ends up here in quantum, creating a one superficial product for us in quantum. His answer was only one thing. Sanjay, the question has the answer. Every Upanishad or everything, whatever I learned, that created a curiosity, because every answer, for example, I don't want to get to specific religion, but if Krishna can be somewhere in Dwaraka, but still appear and give this sari thing at some other place, that's not just Purana or something. That's possible in quantum. That's very much possible in quantum. We are literally in productizing, we are using the same phenomena, right? A power of something being at one place, but can still appear in other place, possible in quantum. So not to disrespect any other religion, if we talk about Jesus, when he's gone and reappearing in few days, where was he? Very much possible in quantum. So the discussion with Devender, what came into my mind is, whatever we read, whatever Puranas, whatever religious books, whatever the form of God, in one line, if I have to explain quantum the way I understand, the same principle I'll go back. Till quantum is measured, it is in one form. And once it's measured, it changes the form. The same thing if I have to relate in the day-to-day, whatever we are doing, whatever we learn, any of the God is a human, right? Wherever we read about God, he was walking, he was able to be nailed, he was able to shoot an arrow. That's all human properties, human tendency. He fought, he wears clothes. God is no different in any religion. You see, God is a human. But once you don't see a picture and once you don't see the belief on him, there is someone called God. He's a human, but the moment you don't measure, you don't see a picture, that belief on him makes him God. This is how I understood quantum. It's as simple as that. I'm not a preacher, I'm not a God man or something, but anything which happened unexplained in the past, which we learned from the books, they're all quantum phenomena, and that's the power of quantum, what gets to the table. So I'm not a very spiritual man too, but this is the best way I could connect quantum to the real world applications, because now that I have said, a classic example of God being God in our minds is a different form. When we see him, when we see a movie about him or something, he's still a human. So quantum has this capacity, which means, in one line, before I move to the second point, I would say there is nothing quantum cannot do which a God cannot do. I'm serious about this statement. Quantum is a disruptive technology. If you think AI is the most disruptive you ever heard, AI is nothing compared to the disruptiveness quantum gets to the table. Anything God can do, quantum can do. For example, there's a concept called teleportation in quantum. I already explained the entanglement. The God being there and coming at some other place, that's called entanglement. Anyone in quantum basics, when you read, you come across this concept called entanglement. Two particles exist at the same place. One particle might be here in India in the college here. The other particle could be on Mars. Could be on Mars. In quantum physics, there's a phenomenon where if you can entangle those two particles, no matter what happens to this particle here, there's an automatic reflection on the particle existing across planets also, no problem. Distance is not a problem. They both are completely integrated together. Effect on one in a way will affect somewhere else. This is possible with quantum. I would say quantum physics or quantum, or for me, don't quote on me, this might be a wrong statement if you use in public platform, but how I see this is, till quantum remains on a paper, it's physics. Once you start using the phenomena of quantum or using quantum technology and trying to get it into application means create a product using quantum physics, quantum phenomena, then it's a true quantum, I call. Till then, it's always just physics. So now I'll get to the hardcore quantum only. To do quantum, anything in quantum, you need quantum physics, a myth. There are 4 segments in quantum. One is quantum computing, one is quantum communication, the other is quantum sensing, the last one is quantum particles. If anyone would be interested after I speak to know what is quantum communications, quantum sensing, after I explain, you have a booth, there's Devender, our young scientist, ask them what it does, right? So only for quantum computing, you need a quantum computer. So first let me address the quantum computing side, computing aspect. It's very simple. Wherever you are using a computer in the classical world is the world we are living today. The world where ex-director of DRDO had done all his research and all, using even the supercomputer today, I call it a classical world computer. Any computer, wherever you're using, whether it's a server or a computer or a laptop, in the quantum world, it's the same. It's a computer only. The only difference is, in the real world, the data travels in zeros and ones. Data stores in zeros and ones. That's called, the storage happens in bits. In quantum world, it's the same computation, same thing. One select star from whatever, it's also same here. The only difference in the quantum world is the way the data travels, right? The way the data travels is anywhere between 1 and 0, but I have promised you I'll not go technical, so I will give a classic example what is the difference between classical world and quantum world. After I tell this example, if you are able to get it, then I'll tell you how it gets advancement. So imagine a coin. Just imagine a currency coin, A coin can never exist heads or tails. In the same way, the data storage or data travel is either 0 or 1. So if you assume head of the coin as 1, tail of the coin as 0, when the data is traveling, it should be either 1 or 0. In quantum world, It's any value between 1 and 0. So just imagine you putting the coin and just hitting it like this. The coin keeps on rotating. In the quantum world, still the coin, still heads and tails, still 0 and 1. But the data, when it travels in the way the coin keeps on flipping. It changes by a nanosecond, which means what happens? When you flip the coin, when it falls, you will know 1 or 0. But when it's traveling in the flipping, if you want to measure it or if you want a result, you just put your hand and stop it. Even if you stop it, still in the flip node, it stopped rotating, but still, till it falls, you don't know whether it's heads or tails. In quantum world, it's all about, there's only one concept of physics. In quantum computing, this is the concept. Classical world, bits. Quantum world, qubits. Here data, ones or zeros. Here, any value between 1 and 0. And the storage unit here is qubit. They just added Q because their ones and zeros here spinning, any value between 1 and 0. By the way, how many values are there between 1 and 0? Gazillion values. 0.01, 0.11, 0.111, 0.11. There are gazillion values between 0 and 1, which means in the quantum world, it's unhackable. Right now, hacking happens. How the hacking happens? The data is traveling, some prime minister office to defense or within the defense, while the data is traveling, or if they hit the server directly, they get bunch of this data. It's all in ones and zeros. So there's always an option to take that bunch of ones and zeros and convert it to what exactly is the data. So that's how all the hacking happens in the conventional world. In quantum world, the same thing, let's assume he had done. He doesn't get 1 or 0, so there's no way he can transform. Only quantum knows whether it's 1 or 0. No one else, when the data is stored in a quantum state, even if you get the most secure information belongs to Indian defense, not even God can crack open that data because they're all bunch of junk values. You can never figure out whether it's a 1 or 0. If you only know 1 or 0, you can hack and you can get the data back. But when you don't know, it's a garbage. So what quantum gets to the table, explaining this phenomena? Enormous amount of security. The kind of security quantum gets. So far, any encryptions, any cyber security advancements, so far, the world had witnessed, all are null and void. Because quantum as such by phenomena, unhackable, it can't be broken. We don't need any of the encryptions, decryptions anymore in the future. Just use quantum, and that's it. Now the second theory of quantum. It's disruptive. Okay, the second most important feature of quantum is speed. Right now, you take the fastest supercomputer in the world, assume there's a particular computation to be done on an enormous amount of data, some whatever unit of measurement I don't want to give, but let's assume the highest data ever handled to compute. If a fastest computer on the planet would take, for example, 10 years, one computation on that much enormous data, for it, if it takes 10 years, same thing using quantum, it takes less than 1 minute. The quantum phenomena, the quantum technology, the power what quantum gets to the table, it gets enormous amount of speeds. I'll go back again. What is light? Light is bunch of photons. Photons are quantum particles. Now tell me, what is the fastest thing on the face of Earth? Light. Is there anything which is faster than light on Earth? Why it is so fast? Photon is a quantum particle. So using quantum, whatever you do, it kind of gets the speeds, leaps and bounds. One computation, one thing. Right now, I put a video on YouTube. We are in the world where I'm still getting that round. I was attending a Zoom call from your college, my meeting. 2 times it got hanged. That's the era we are in with the 5G advancement. Now, guess what happens if on the telecommunication network, if it is upgraded to quantum technology? Let's assume, right now 5G, 4G is the speed of your internet, okay? So 3G was lower speed, 4G was little higher, now 5G. The same telecommunication tower, you upgrade it to quantum technology. I'm not talking about 5G becoming 10G. I'm talking about 5G becoming 10,000G. That's the kind of speeds quantum gets. So extremely secure, superficially fast as light. With these two kind of advancement, what quantum has, it's disruptive. Using these quantum properties, there's nothing you cannot do in the world. You know, at this point, I'll just leave it here. I want to create curiousness in each one of you so that you don't need books, just go to Google's and say basics of quantum. Don't say quantum computing, basics of quantum. You will get all these theories. I want you guys to understand more, and then we will definitely have another quantum awareness session where I'll go a little more technical. So I just wanted to create the interest. Quantum is disruptive. Everything in future is quantum, statement number 1. Future has to be quantum, statement number 2. There's no other option for us. Future will be quantum, statement number 3. I'll tell you why. With this kind of disruptive nature of quantum physics phenomena-based products coming into market, it's so disruptive that using quantum, there's a bad thing also you can do. Using quantum, you can hack anything and everything. There's no system safe today. Even US defense, US president's communication is also no longer safe. Using quantum, fortunately, quantum hasn't evolved to a point where it is in the common man's hands. Quantum is only with people, research scientists in DRDOs or Indian defense or some of the very few startups like us who are able to productize something in quantum. It's by grants, it's by permissions, it's by regulations. But what happens if a quantum technology or access to a quantum computer to write algorithms, there are qubits and all, I don't want to get there. He will write, if he is a hacker, if he's writing algorithms in a conventional world, in quantum world, he can write it more simpler. What if he writes an algorithm to hack open Reserve Bank of India? What happens if he cracks open our Indian defense communication? The country's economy goes back, like these are direct impacts. One attack, if you take down the stock exchange of India for 3 days, our GDP will move back 5 years. I'm telling you seriously. That's the kind of impact this hacking has. And using quantum, you can crack open anything and everything. There's no encryption which is safe anymore. Any of the cybersecurity people here, the highest level of encryptions or the most popular encryption is RSA. Even a lot of defenses, including American defense, use RSA encryption. RSA encryptions can be broken using quantum in less than 7 minutes is the claim. Unfortunately, it hasn't evolved to a point. It's evolving, but it's not too late. Someone in China already hacked the lower version of RSA, which means to come to this 2048 is not going to take too much time. So the second topic I want to cover is on the quantum threat. I just gave you the basics of quantum technology as such, and how much time do I have? Rajalakshmi madam? Huh? 1:05. So with this kind of disruptive technology, this is a threat which is coming. The world is all working towards how do we handle this threat. What China had invested $13 billion only in the quantum technology so far. Just imagine how advanced they are in quantum, whereas India, it has only allocated 6,000 crores. 6,000 crores, National Quantum Mission is still 0.6 billion. We're talking about China, 13 billion. What happens if China gets leadership in quantum? There'll be a technology war. In future, whoever gets this leadership in quantum at the country level, they are the people who are going to remain. They are the people who are going to become superpowers. This one quantum is going to change entire ball game of so many things, like it can convert a superpower into almost zero, or it can convert a zero if any country gains this advancement in quantum. Automatically they can take over the world and they can become superpowers by years, few years, less than 2 to 3 years. Someone can become US. Well, US can go down. Of course, US has invested $3 billion. So far, only 13 countries have invested. So this quantum threat, quantum can break anything except quantum. Quantum, the only thing quantum cannot break is quantum itself. So how do we all become safe from all those quantum attacks is adopt them to quantum itself. We have to make India quantum secure. There are short-term solutions, long-term solution. The long-term solution is there's a communication network country level. Some of the big heads here would understand exactly what I'm talking about. There's a communication network at country level which always is owned by the country. Everything is leased. All these Airtels or Geos, they lease from the country. So the country level communication channel has to be upgraded to quantum using quantum technologies. It's a combination of hardware and quantum software. Most of it is quantum hardware. We use this quantum hardware and we enhance the communication network and make it quantum safe. And the key product, one of the key product is called quantum repeater. So we are in the game. All our products, whatever we make, not only us, there are 12 companies in India, as I said, who are productizing in quantum. All our products is addressing on how to make India quantum safe. And there are 2 products we are demonstrating. Anyone interested, go. He will explain you what those product does and those kind of things. So I talked about quantum computing, which is a conventional computer, quantum computer, heads and tails, coin flipping, that's computing, over. The second point I have covered is entire country should become quantum safe, which means what will happen? Anyone using quantum attacking something in India, the communication channel itself, it restricts. It cannot even come into. Whereas the short-term solutions is every organization working in India, by organization, we have to become quantum secure, like defense has to become quantum, RBI have to become quantum. This is short-term, but the long-term solution for every country is becoming quantum secure at country level, which means using quantum. The only thing quantum cannot break is quantum. When someone uses quantum and hits, it is like Brahmastra versus Brahmastra. You're safe there, nothing happens here, right? So this is quantum communication. The second area is quantum communication. There's a huge application, students, for you guys, electronics. Whoever is electronics, electrical, huge application is quantum communication. Quantum communications, none of the hardware products need access to quantum computer. They don't have access to quantum computer. We use quantum phenomena, and using the quantum phenomena, we trap it into a hardware, and we use it as part of the telecommunications network. In one line, if you meet Devender in the stall, he'll explain better, but in one line, what we do is one of the component in this, we call it quantum key distribution network. This quantum security at country level is called quantum key distribution network, and one of the component is quantum memory. I'll give you one example so that you'll understand. What we do in quantum memory is, we take bunch of photons, no quantum computer and all, one box. We take bunch of photons shot by laser. We identify one single photon. Just imagine identifying one single photon. The photons travel so fast that you cannot handle, you cannot do much with that speed. We take one single photon, we slow it down. Only if you slow it down, you can play around. We slow it down, we store information in it, and then we leave it. Then this goes lightning fast. Same at the retrieval. The same photon had to slow down so we can retrieve the information. Using quantum phenomena, using quantum physics, in one box, we do all these things. We are India's first to have ever created room temperature, rack compatible quantum memory. So in the entire little box, this whole thing happens. Every nanosecond, photons are storing and going. So this is productization in quantum. Till you make use of the quantum phenomena, convert into products and using, you are not doing anything. The application, if you want to get leadership in quantum, it has to be applied. So this is quantum communication. Now the third part is quantum sensing. Quantum sensing is scarily beautiful. Quantum sensing is going to be a game changer for the world. Same concept, using physics phenomena only. We use quantum particles only. I will only give you one example. At one place, quantum sensors, any place where you are using sensors in the conventional world, you can use quantum sensors. But the only difference is, one example I'll give, rest. You assume use your imagination, where all it can change. Only one place I'll tell you. There's an MRI. Let's take conventional MRIs. Today, you have a fracture in your hand, you go to X-ray. Okay, the doctor takes X-ray. X-ray just gives the nakedness. It doesn't give any magnification. So doctor sees the X-ray and oh, there's a crack. But if there is something very fine and the doctor is exactly not able to get it, he sends you to MRI. Now what MRI does, it gives nakedness and it also gives you magnification. So that the doctor can see better. I'm talking plain English. These words cannot be used. Magnification is never used in healthcare. Resolution is the actual word, technical word, but for you to understand, I'm telling. So MRI gives you little magnification. MRIs have RF sensors. It measures electric pulse. Now what happens if these RF sensors are removed and replaced by quantum sensors? Quantum sensors don't measure electric, they only measure magnetic. Guess what? With quantum sensors, same MRI. MRI can give you 10x magnification to a little more than tissue level. Quantum sensors can give you magnification to the cell level, which means 10x magnification is going to 10 lakh x magnification. You're talking about the smallest particle of the human body, which is a cell. Quantum sensor can measure each cell's magnetic pulse and tell whether that particular cell is good or bad. Every cell. Guess what? In future, all you guys students, I don't know if we could live up to, for my age, I could really see this transforming, or maybe I will see because I'm creating as a quantum sensor. Future cancer cure in future, very near future, talking about 3 to 5 years from now, is a walk-in, walk-out procedure. Just imagine what is cancer? These bad cells exponentially multiplying by hours. What if you can have a map of, okay, this area is cancer. What if I can give you a map which says, these all cells have 100%, these all cells have 10%, these all have 5%, these all have 0.001%. If I give you a thermal map using quantum sensors, only using quantum sensors, it's possible. They give you resolutions to, if anyone know the unit of measurement, femtotesla. That's the tiniest particle magnetic field could be measured. So the doctor takes a radio, some probe, very small probe, he takes that map, he keeps on popping every single cell. There's a color code, even if it is a 0.00001%, still will show. So, okay, maximum what will happen to kind of eliminate or to kind of remove each cancer cell, it might take an hour. Or maybe with the advancement, it might be like a tongue cleaning, there might be a scraping also. But either way, I'm telling you, if every cancer cell in the body is already killed by whatever means, it's a walk-in, walk-out. There are cells which are killed, which means there's no major body damage. They'll give you one apple or orange juice or fruity, whatever, and they'll say, go home. Because there's no cancer cells to double. Cancer is gone. Every cell popped out, walk-in, walk-out procedure. If you're removing a tissue, cutting a tissue, then healing and all, you're killing few minute cells of the body. Nothing will happen to your body. Come in, cancer, scan, get out. This is the advancement quantum sensing is going to get. Not only in healthcare. Healthcare, lot of applications. You're talking about the precision medicine. I don't know how many people know. Precision medicine is, Okay, one powerful statement. Prove me wrong. Anyone here do research and prove me wrong. Quantum has a power to predict a disease. This is like the sci-fi movies. To predict a disease, whatever would come 4, 10 years from now, and cure it before it comes. Can you believe quantum has this power? Predict a disease which comes 10 years before, that AI also can predict. I think they can take genes, genome and all, 80%, 70% prediction they're claiming. But can it cure it before it happens? This is quantum, guys. This is future. The entire world have to move to quantum. I started from there. Why we have to move to quantum? Global threat, quantum security, every country has to get. Quantum computing, I told you, lot of these problem statements, what we are not able to address in the conventional world, with the kind of speed it gets, everything can be computed. There's no problem statement will be left. Quantum sensing, game changer. We will all be really living in a sci-fi world. There's another concept in quantum which I didn't explain, which is called teleportation. Teleportation is nothing but, this is also a sci-fi movie. Anything, atoms can be disassembled here and get reassembled somewhere else. Like, for example, there's a guy in Switzerland who had claimed that he had disassembled a tissue paper and completely disassembled a tissue paper and reassembled it 4 feet. If one can do that, this is possible in quantum, theoretical. This is, I'm not saying lies or anything, go to Google. Only in quantum physics, there's a phenomena called teleportation, very much possible. A lot of people are doing research on it, and this is going to be reality very soon, which means today you're eating something in the canteen or something. Maybe tomorrow you can say, Dad, my canteen is giving me all bad budgies. It tastes so bad, I'm sending you. Eat and tell. Very much possible with quantum. This is future. So I only touched the basic top 2, top 3 things in quantum. There's so many more advancements. Again, don't get stuck to quantum technology. Look into quantum phenomena, look into quantum physics, and get interest. Everyone has scope. Everyone has their own piece of cup, irrespective of mechanical, electrical, or even English. Madam, even English people can come to quantum. Seriously, if you've done your basic intermediate, and if you use your best common sense, then just read your intermediate physics book once again, you can productize quantum. It's enough. You're talking to someone who's not a physics person, you're talking to someone who's not a doctor, I'm just a businessman, and if I'm able to understand and productize something in quantum, each one of you can do way better. And you don't need people like us. Seriously, there are 2 people I just talked to today. Both of them have already done so much in quantum, retired, and they came here, right? Right before me. DRDO had so much quantum, Baba Atomic Institute. They all had done quantum. You have this faculty before you whom you can reach out and help yourself. And the last part I would like to cover here is, so basics of quantum covered, why quantum, quantum is future, 4 segments in quantum. The 4th segment is quantum particle, quantum computing, quantum communication, quantum sensing, quantum particles. There's something called quantum particles. Right now, we are all using only photons as quantum particles. There are a lot more quantum particles which world is researching, which could be accessible. This is super fast. How do we, the better quantum particle, better stable quantum particle we can get, the advancement would be more. Right now, photons are so unstable. To control it, it's like hell. So you need to have a better stable quantum particle so that the evolution happens. The last aspect and last 5 minutes I'm going to talk is something. We talked about quantum, so what it means for you students, it's up to you whether you want to stick to the basics or you want to move to quantum. I have given you a scope to understand the basics of quantum. But remember one thing, guys, this is extremely important. I know this one last 5 minutes, some of the students might feel boring because it might, you guys might feel like preaching, but no, I'm not preaching. I'm talking about some of the facts. If anyone decides to come to quantum, if anyone wants to choose quantum as your careers, guys, remember one thing. Whatever you want to do quantum, now this is not this computer science, this is not those basic electronics. It's way higher. Half of quantum is built with optoelectronics. So whatever you want to get in, whatever you want to do in quantum, please choose a path which could lead to productization, or it could lead into infrastructure. None of the theory what you learn is neither going to be useful not to the country, not to the education institution if you are learning it as a theory. Theory is books. If you really keep quantum as a theory, it's just physics. It goes nothing else, it's waste. But choose your theory which could end up as an infrastructure, which means any advancement, a book-ish theory will not get advancement. An experimentational setup will not get advancement. A theory should always result into a product, still it would not get you advancement. A theory which gets converted to a product and applicable, means either sellable or getting used somewhere. I can keep a box and say, hey, I have created quantum repeater. But if it doesn't integrate into any of the telecommunication network, it's just a box. It's piece of a theory physics. So till a theory would not result into an application, learning the theory is entirely waste, useless, time wasted. So any of you would love to come to physics and learn something in quantum, pick the theory which could be converted into application. Just don't pick these projects just for the sake of it, I want to do something in quantum. Your first goal is, okay, I want to go this or this or this. Then see what could be really, not all theories could be productized. Some theories are only to understand physics, but they cannot be productized. See what could be applied towards end, and then do a backtrack and choose that side of physics. Because what India lacks is, I don't know how many times you heard, every technological advancement India lost, mostly to China or Taiwan or US, like we lost semiconductor to China. We lost AI to America is what they say, but I don't believe. We lost AI also. India only won in one place, computing. India won only in one place, which is software. India is only superficial in software. As of today, if India had won anywhere in the technology advancement, it's software. Now, is it helpful for India? No. Every software, good software is in US. Every good software is in UK. But still, India has gained technology advancement is only in software. We lost AI, we lost semiconductor. Why I'm telling you, anyone who wants to do research, you guys are future innovators. You know, we have done whatever we have done. I'm here to help you if anyone's seriously interested, but anyone picking the topic of research or even to decide to read, pick the application first. In that application, where all quantum is there? If you get 10 or 20 different areas, which area interests me? Then start learning the theory from that side. And on a closing note, I would like to only say one thing. We all should be patriotic about our country. Country first and everything next. All, before I leave the dais, I would leave with one question to each one of you. Once quantum evolves, once quantum's application 100% starts, around 2040 or 2035, each one of you, would you like India to be a consumer in quantum, or would you like to make yourself, your college, your state, India, a quantum architect? Rest is up to you. Thank you, guys.
Thank you, sir, for that insightful and inspiring session. Your talk has helped us understand how quantum technology is not just shaping the future, but actively redefining computation, communication, and cybersecurity. Your ability to connect complex scientific concepts with real world application has truly broadened our perspective. It has been a privilege to have you with us today. I now request Dr. Ilavaragan, Director Research, to honor the speaker with a memento.